a Starbucks in it and has been redone, except for the one in Lawrence and the one in Clinton, are the only two that I've ever seen that don't have a Starbucks and haven't been redone.
The one in Lawrence had the nice flowers.
Do you want to know why?
Yes.
Because the type of person that goes to the Clinton Ingalls is
boy.
my former economics teacher, who cares mainly about the price of a fresh avocado when he goes to Ingalls. He cares far more about that than any other aspect of the Ingalls. So much so that most of his lectures somehow involve the price of avocado. So it's likely to do with the clientele they have on average.
Well, you know, if they had a Starbucks in that Eagles, I would be there
I got
every
it.
day.
I'm so
It was
proud
a
of
little
you.
wonky, but I'm proud.
I'm so proud of you.
I appreciate it.
You would absolutely think that stores around here would.
Capitalize on the fact that there's a college, but they don't.
Except for our college is the size of a high school, so they just don't
Still.
My high school was
but
3
with
times larger than
businesses-
this school.
care. So was mine.
But like with businesses this small and this like local that are already like focusing on a small amount of people, it's a big group of people to target to.
Not
So
to mention
the
the fact
Domino's.
that between here and Lawrence, there isn't
What
a
did you
movie
say?
theater even for the locals.
That's what I thought you said. Yes, I do. I have the orange juice.
I think that we're missing a lot of things that locals could enjoy that the students would spend a lot of money on if they existed.
Like a bowling alley,
There is one of those. Oh wait, did it close?
they closed. Or a movie theater.
Yes.
I wouldn't.
That's the main thing that I would try to open here if I had
Or
money.
like a putt-putt place or like anything.
I would say a cookout.
Yes.
It's
Okay, y'all, I thought that Burger King was gonna be a cookout because it was a little box, just like a cookout, and I was so excited, and then it was just another
See,
Burger
if
King.
it was
The same thing
cookout,
happened
a
in my
lot of
hometown
college
or
students would
something.
go there because it's cheap. High school students would also go there because it's cheap.
And it's open all night.
It's open all the time, so
Which is
then you
why Waffle
also
House
get
gets
the
business.
26 traffic going to cookout.
Let's get that, it's just good.
So I think we should become the new town board.
I think we
Yes.
should.
There's all of those empty shop fronts
I have
downtown.
another idea, a bar. There's
So,
no
wait.
bar.
Okay, like this is like real life intel from Press. He was talking to some of the senior giving campaign members, about,
Are those the people trying to sell bricks?
yes, you wanna buy a brick, please buy one for
I
me.
don't.
I have no friends.
2 of my friends selling bricks and no.
So homeboy, sorry. President Vandenberg. He's talking to us, and so the like storefront between what used to be Jitters and Steamers, you know what I'm talking about, it's empty now, is owned by PC, it used to be the bookstore. And he like wants to like renovate it, to like make it something that like students and staff can like hang out in, like a brewery or like some kind of hangout
Yes.
space. So Homeboy has like big plans for this
Scottish
little town.
micro pub.
Yeah.
Yes, like something.
I don't know what the hell.
Well,
any
my-
of these things are.
If I come back for homecoming ever.
Me neither.
My great uncle went here when the bottom floor of Georgia was like a speakeasy.
Yeah, it was like a coffee shop.
Like a coffee
That
shop
was
that
before
low-key
my
served
time.
alcohol.
My mom
When I
went
was
here
a
in
student, the
96.
bottom floor of Georgia was laundry and then sketchy haunted closet.
Yeah, it's like the sketchy haunted closet, but the outside door is like open. Cause I've like gone in and out of it.
I'm
The
convinced.
like
like,
basement of Georgia?
If anybody.
Oh, the elevator took me down there one time and then left me. I pushed the 4th floor button and it took me to the scary part of the basement and then left me there.
The
And that's why I don't use the elevator anymore.
the cute little house, like so if you're at admissions, there's like a cute little house in the corner to the right. That used to be like a dorm. My mom lived in there when she went to school here. And it's like this cute little house and it's so quaint and dear. And now we have grossness and barren. Yes.
I haven't heard it called grossness yet. I stayed at Barron. It's just cinder blocks.
Yeah.
It reminds me a little bit of
Yes.
this.
Yes.
Give me cinder block.
When did it become like, cause you know like when your little classrooms are decorated so like happy and colorful, even in like high school, why did that
That's my
stop?
high school.
My high school is not decorated. My middle school was, but it was a K-8 school, so we had like the added benefit of children being nearby.
I think those schools, you're more likely to have your classroom that you can manipulate. This is a lecture hall, and I have very little control over what gets displayed.
Lecture hall is a really generous term.
Sorry?
I said lecture hall is a really generous term.
Okay,
for
but
the
there's
rooms that
only
we're in
7
right now.
people.
The quotation marks were implied.
Why is this? Not understand.
Is that a positive 5?
Mine was a negative. And then when you multiply it by the
Yeah, sorry,
10
it's
to
a
6.
negative. It is a negative. I like didn't write it, but it is a negative.
Gotcha.
My bad, guys. All right, let's pull up my homework. Right now, she's sitting at
Oh, I forgot. I just
35.
forgot.
You're crushing it.
I've done it 4 times. I keep taking it off and then I press the button and I'm like, it's still in. It's not luck.
Okay, so there is 8 questions on this homework,
I've got all
and
of
we can
them.
spend time talking about as many or as many as you want.
Wait, let's start at
We do number 5. I urgently need to understand number 5.
Urgent. Which one is 5 in planes?
No.
5 is up.
Oh,
Alright.
did you draw that from the-
I tried really hard on this one too. It just really didn't.
Okay. My only bias in which ones we look at first are based on the ones I already have on the board.
Fair enough.
We can do the ones we're gonna need all of them, so if you want to start with the ones on the board, we're okay with that, as long as
Okay.
you get to the ones that aren't on the board.
Okay. I kind of want to start with the ones on the board so I don't have to rewrite them.
Fair enough. That is a nice plane. Very good.
Thank you.
Yeah, who drew that? Did you draw that?
Yeah, I wrote
That's so much
things.
better than my plane.
That's called growth. right
Where is
there.
my plane?
Thank you.
Look at
Oh, of
mine.
course, it'll
Look
take
how
4
awkward
weeks
it
to run.
is.
Aw.
It's, the front of it is so long,
You
and
said,
this wing is so
"Oh."
much bigger than the other
He's
one.
stretching.
So it's Nemo.
Yeah, like it's so
Don't worry,
awkward.
you know, into this. You can do anything you
Look. Everyone can chase their dreams, even awkward ones. That said, they shouldn't fly into thunderstorms. Okay,
I just truly don't understand why I keep getting this wrong.
well,
Are we starting at number
yeah.
4?
Only because it's already up here. I want to get through all of them with you, I just don't want to have to go redraw it. And then if we do this one, then I can clear off some more. So, 4. But again, formal announcement again for everyone and for the camera. Homework and quiz are delayed to midnight on Thursday. So you can come back with any questions on Thursday and we'll check everything.
Thursday, guys. Delayed till Thursday.
Hey, note to self, do not watch this video.
Okay, number
Just
4,
watch it.
plane. The numbers have changed since I wrote this last. Great.
Oh boy.
But the physical situation is the same. We have an airplane that is making a poor life choice and flying directly through thunderclouds. The plane is at a known height from the ground. So that first height given, the numbers may vary. On the screen right now it is 1850. I will change what is on the board accordingly. If I find this marker. 1850. So that is the plane's height above the ground. It's worth remembering what this is in reference to. We are then told, functionally, the way that I've drawn the picture is that this plane, rather than describing it as flying through one cloud that has a different charge differential at different points, I'm drawing this as flying through between 2 different clouds. The first cloud given to us has a net charge of positive 40 coulombs, which, physically speaking, is absurd. And it is at a different known height. So this second number is cloud 2's height above the ground. The numbers on my screen list that as 3,400. And I'm listing the variables as height plane and height positive 40 coulombs. So this plane is beneath that cloud. The second cloud listed is negative 40 coulombs, which is also absurd. It's at a fixed height of 1,000 meters. Everyone will have that same number. So height of the negative 40 coulomb cloud is 1,000 meters in the air. All of these heights are in relation to the ground. We can use them to figure out how far apart each of these objects are from each other, but the starting numbers are in reference to the ground. Keep that in mind. What we are asked to find is the magnitude and direction of the electric field at the height where the plane is. So each cloud is going to independently generate its own electric field. So at the spot where the plane is, there's the field coming from the positive cloud and the field coming from the negative cloud. Those two fields are overlapping and adding together at that one spot. So we need to find the field for both clouds at the plane's location before we then add them together. Before we do that, I want to address the direction of the fields. Positive objects exert fields out of themselves. So from here to the plane, the direction of these field lines is going to be straight down. Meanwhile, negative objects exert fields pointing into themselves. So from the plane's perspective, the field generated by this cloud is also going to point vertically down. So if hypothetically we found this, the positive cloud's E field to be 10, magnitude of 10, and we found the negative cloud's E field to have a magnitude of 10, what would that make the total at the plane's location? 20. They're pointing in the same direction, so they're going to add together. There is a disconnect between the signs of the charge making the field versus the signs when you add the fields together. Because the sign of the charge only cares about field outward from that point or field inward to that point. It doesn't really tell you up, down, left, right, north, south. That's where the picture comes in. This picture is telling us both clouds, from the plane's perspective, are creating fields that point downwards. So they're both going to add up to create a bigger field downwards at the plane's location. So what I've done on the board is the formula we would want to use for the E field from each cloud is K times Q over R squared. I put absolute values around each individual E field because the negative 40 coulomb cloud is negative. If we plugged that negative in and did nothing else to it, this E field would be a negative number that we'd be adding to a positive number. So we would get a smaller answer than we should. I put these absolute values up here to get rid of that negative. Because in translating from the drawing, the math, the original statement of the signs, we have to kind of assign the direction ourselves. So the absolute values are there to reset all the directions and giving us control over what direction each of these point in our math. Should also go ahead and change these. So ultimately, after the absolute values, both of these, both K, Q over R's, should become positive. They're going to add together to a bigger positive number. And within the WebAssign answer, the number goes there, and then you choose the direction. They're both going to add up and point down. We know what K is, we know their Q's, and we can use their height from the ground to figure out how far each one is away from each other. The distance between positive cloud and plane is positive height times plane height. Distance between the plane and negative cloud is plane height minus negative cloud height. So this one does highlight that unfortunate disconnect. And that disconnect is the reason why pictures are kind of necessary. So the old order of operations for physics questions, where you are given a situation, you read the question, you list the things you know and don't know, and then you draw a picture. That's an essential step for a lot of these. Because otherwise the numbers alone wouldn't tell you that those two fields should both point down and add up. Questions about that one?
Can you explain the signs one more time?
Yes. So within WebAssign's answer, they've separated direction and magnitude. So it's not looking, even if it did point down, it's not looking for a negative number. So what we care about is to find the number that is the magnitude of the fields added together. And we know from our drawing, both fields are pointing down when they both pass over the plane's location. And since these are two vectors that are both pulling downwards, they're working together and they're going to create a stronger field downwards at this spot. So we do need to add their two numbers together. And I added the absolute values. Since one of their charges is negative, we don't really want this to come out as a negative number because it's going to work against this positive number.
So when they're pulling apart, does it matter which one you make negative? Like if they're pulling in opposite directions and you add it, you have to make one negative?
In that case, you would still need to know which one is negative. You would need to know which one's negative because you need to decide what direction the negative answer is if you get the negative. Like, say for example, well, if these were both positive clouds, then this arrow would be reversed, and one would push up and one would push down. So one would have to come out being negative so that you knew how much they were working against each other, even though they'd both be positive charges. So for E-field vector addition, the signs, you kind of have to add in yourself right here. Individual fields, the normal formula is fine. Positive or negative just tells you outward or inward. But the addition requires the picture a little bit of. And I don't really like that disconnect because it's hard for me to give you a rule for it. Which is why I want to spend today looking at each of these situations. But they're all weird and different, and it's hard to give you a generalization when every single question is weird and unique. Any specific questions about 4 right now? Okay. That one's 6, I think. I'll let you guys pick. Because if we're okay with 4, I can erase it. I've got 6 over here. I forget which one's back here. It might be 7. I've got 7 behind the screen. So we can look at 6, 7, or I can erase 4 and we can look at the other one.
You can look at 6 and 7 and the direction 5.
Okay. You've already mentioned 5. But we are going to do 5. The others as well. Okay, so 6. The Van de Graaff generator is the that term is unfamiliar, I don't want people to get too hung up on what that is.
Don't worry, I just wanted to.
These things, science class as a kid. It is,
Does PC have one?
we have lots of broken ones. And I have yet to take a summer to try to figure out what parts for each one work. The R and R type slang off.
This is all only the R.
So in the question, when it says Van de Graaff generator, we have a metal orb that is designed to generate charge. So for those machines, turn on the switch. The generator causes this to build up some charge. Some build up positive, some build up negative, it just depends on the construction. This particular question says that this particular orb has a charge. That means it is exerting an electric field. And we then, after that fact, drop a proton right here. And the proton is then pushed horizontally outward and away from the orb. From that situation alone, what positive or negative charge, what charge, positive or negative, does the orb have? Positive, very good. So it is exerting field out from itself. I realize I already have pluses and zeros on there. So, we know just from the physical situation, orb is positive. We don't know its charge, but we know it's repelling a proton. And we know at least two things about every proton. So this is just the mass and the charge. Regardless of anything else the question gives us, we have these. The question goes on to say that the proton gets rocketed away, accelerated away from the orb at some known acceleration. And the first thing we're asked is, what is the electric force between the orb and the proton? So, sorry. So from the fact it's a proton, we know its mass, we also know its charge, and we're told its acceleration as a result of the electric force acting on it. So we want force, those are the things that we know. A little bit of a flashback, but Newton's second law still works no matter what physics class you're in. So, and in this situation, the force is going to be the electric force. So, the force from the Van de Graaff generator is going to cause the mass of the proton to accelerate. And I wrote up here in the mass in kilograms, because that's what our formulas are designed for. I know grams gets thrown around a lot upstairs. Part one is just finding that force, the force acting on the proton. Since it's repelling, the direction is going to be outward instead of being pushed away from the generator. So, Newton's second law to tell us the magnitude, and the force is going to point away from the orb. Second half of the question, what is the E field that created this force? This is an electric force, meaning that an E field from a second object had to create it. We have two formulas for E field. The one we've used most often together is the KQ over R squared. Does that help us in this situation?
No.
No. We don't know the radius of the orb, we don't know the charge of the orb. What we do know is the force that the field is exerting on that proton, and we know the charge of that proton. So this proton is basically a test charge in the E field being created by this orb. So you take your force answer to part A, divide it by the charge of the proton. And that would tell you the field strength required to exert that force on that charge.
Why is the unit in over C?
That's just the unit for E field. The unit for E field is N over C because E fields exert force in newtons on objects with charge. And that's what we see with this one over here. Maybe divided by 2 lumps.
So what is the point of it asking us the direction? Because it tells us the direction in the question.
It does.
But I still got one from Paul.
Good job.
You're allowed.
I'm asking the dean is pretty silly.
Play nice. Only constructive criticism here.
Silly is pretty nice for Gary.
I'm usually very nosy.
Is it just like to give us more points there? Like,
Probably.
okay.
Try to help people like me.
It is the answers are both vectors. The direction matters. But since technically the field is pointing literally in every direction but outward, it's not a simple positive or negative number wouldn't really suffice. So it may have complicated it one extra step. Got some temple rubbing and some maybe confused faces. How do you guys feel?
I totally forgot that first you make me.
I was putting part B's answer for part A, and so then I didn't know what to do in part B.
Bruce?
I was just being overcomplicated.
Look, it's physics, it's complicated. Sometimes we make it more complicated than it needs to be. Sometimes we don't make it complicated enough.
Always complicated.
By which I mean there's like 20-point questions on the test and someone will use a much shorter, much wronger formula to get an answer quickly. That isn't what I was hoping for. But other times we just, granted, again, this refers back to the picture, I think. I think that this is specifically homework where you need to draw one for most of the problems. Kind of like how 6 flashed back to needing Newton's second law. Come on.
7 had the spring constant.
7 brought spring constant back, yes.
I remember that first time.
So the 2 parts of 7 are separated as part A, which is just an old spring constant question, no electricity involved. In this situation, you've got spring hanging from the ceiling, mass hanging from the spring, force of gravity pulls down on the spring stretches and exerts spring force upwards on the mass. You want both forces to equal out so that the mass just hangs stationary. Figure out how far the spring must stretch in order to do that. So, and again, if you didn't learn it the first time, force equals spring constant, which you are told by the displacement. So, since it's just the 2 forces, the spring force should be equal to the weight of the hanging mass. That force divided by the spring constant will tell you the distance of stretch. Be mindful of the units on the answer, because the formulas give us meters, and the computer's asking for centimeters.
When we're doing this, is in the second part where we have the equilibrium set up, so it's force of gravity plus the spring force plus the electric force. Are we looking at in the spring force is X what we're solving for, or is X what we got for A?
You're still solving for x. So when moving to part B, it's the same spring and the same mass. What's different in part B is the mass now has a charge, some known charge acting on it, and there's now an electric field pushing upwards.
How? Hang on. Okay, so then with the electric field, that's gonna be, what formula would we use for that?
Good question. Mass is now a positive charge, has a positive charge. E field points up, so what direction should the electric force point? Up, yes, exactly. So it's going to work against gravity, it's going to be a second force upwards. We know the E field, and we know the charge of the mass. So just this first part here can tell us the force itself. So I consider this step 0 for part B.
We know the E field?
Yes, slowly increasing to a maximum of this number. Whatever this number is, you can just plug it in for your input.
Excellent.
I don't know why they specified slowly increases to maximum, but physically what's going to happen is the mass now has a charge. The E field is going to cause it to slowly float upwards just a tiny bit, and now it's just going to stay at that new, different stretch length. Yes, sorry.
This might be a silly question, but what is G again? How much is G? Is that the 9.2?
It is.
There are no silly questions.
I encourage questions that one might think to be silly. Because I can still spin a physics lecture out of asking you what a lightsaber do. I said it like that. So the only difference from first to second is the addition of a new upward pointing force. That's just going to cause the spring to stretch a little bit less. That's not a real difference. You guys are working based on that. I'm going to fill my water up real quick, and I'm going to clear the board for other questions.
And it should be a smaller number?
It should.
That's not good.
Oops. So, looking here at the sigma F, gravity pulls down, spring force pulls up, electric force also pushes up.
So that means, so the spring force is a negative number, according to the spring force formula. Do I need to switch that to a positive, make gravity negative, and make the electric field force positive as well?
From the mass's perspective, free body diagram time, gravity's down, electric and spring forces are both up. Because they're both literally pulling up on the mass.
835 is the F spring.
That's the number you have right here. That is
Yeah.
the K of the spring.
Oh, okay.
And this formula here, it's called Hooke's law, has a negative built in, even though I really don't like that negative. It's there because if you, say you have a spring and you stretch it to the left, the force that it exerts on your hand would point to the right. Because if I'm pulling this way, the spring's going to pull back in the other direction on my hand. That's the only reason the negative's there. And technically speaking, we're stretching downwards in both of these cases. So since the delta x points down, the spring force would then be made positive, but a negative inside of the formula. I don't really like that it's there, frankly.
Wait, that was
Oh, in the Hooke's law formula.
the negative?
Right, that negative right there.
So, when we're putting in the numbers, the force of gravity would be negative and the other two would be positive?
Correct. just looking at everything add up to 0. Gravity pulls down, spring pulls up, electric pushes up. How you feeling?
So what if the number that I got is larger?
That happened to me in my science.
How about I use the board numbers myself and we'll just see what happens.
Okay.
Yeah.
Okay, so we're gonna do part B, because we don't need any of the answers from part A to do part B. Sum of the forces equals Fg, so mass, 3 kilograms, times negative 9.81,
I don't like the first one except for the second one.
plus force spring, plus the electric force. We know from our other formula, electric force will be E field times charge. So that's just what I'm going to go ahead and put in. Our E field is 335. Our charge is 0.045. And those need to add up to 0. Now I'm writing over things. That means if we send both of these numbers over to the other side before solving for anything, that would give us 3 times positive 9.81, because we would make it negative sending it over, minus 335 times 0.0, oops, 45.
Okay, I got it. I was missing a negative somewhere, I think.
Okay. Okay, for spring force, I'm getting 443.66.
Tiny.
That's spring force.
Multiply by
Already did, but the last
That
time
would
it
be
was
equal
so
to
tiny.
well, that's not good.
our K, which is 800, times our delta X. Delta X will come out as, wait, what?
Wait, I thought you said those were positive. Oh, okay. Did you get a bigger number too?
Uh-huh. You know it's not a good sign when the teacher says, wait, what? Ow. That's the charge. Oh. I didn't put a negative, I didn't put a minus sign in my calculator where one belonged. So it's not 400 something, it's 14 something. So instead of 400 divided by 800, it's 14 divided by 800. So that makes my delta X 0.0179 in meters, which would be 1.79 centimeters.
Well, I haven't said that I've never once understood physics, so. Alternatively, I've never
You're
understood
fine.
physics.
That's all.
Number 5. I could not, I don't know.
I know that you have some understanding of physics in your head, because even if you're not doing calculations, you still know, like when you're driving, wheel must turn this way to put car in this much turn. You have some conceptual understanding, even if you don't do the math every single time.
Yeah,
It might be instinctive, but there's still physics in there.
The issue is, my dear professor, is that we're graded on the math.
There you go.
Right, so I'm
If
gonna
we
try to
can't do
help
the
you
math,
turn
we
that
write the
instinct
paragraph.
into
The
numbers
instinct.
as best I can. Someone asked for a bathroom break. I need water, and I'll use that chance to erase the board and put some new ones up there too. So,
Just in case you wanted to know, I got 1, 2, part of 3, and 5 wrong, so
1, 2, part of 3, part of 5.
all of 5, only one of the 6 points in 3 is wrong.
Okay.
I would be okay if
You
I didn't
said
get
five.
that.
5 is something that I think multiple people mentioned at the beginning, so
Yes.
that one seems like a good one to look at next for me, especially since it's a triangle.
Not to be confused with
What part of 3 did you say?
the magnitude of the second one. I'm sure it's like a sine thing. I just don't know why.
There's something in my mind.
So it's the one in the middle.
That's just the answer.
Yes, because it's minus a negative. It's this it's this sum.
Extremely.
Yeah, so like it's this part minus this part, and you get a negative number, so you minus the negative. Or it's like you
Positive is repelling in, and the negative is pulling it out.
Yeah. Because the negative is pulling.
Sorry.
I think we have the same numbers.
I actually think we do.
325.
Yes.
Yep.
You don't have to do number 3.
Okay.
Maybe not for them.
Sorry, I did not mean to speak for you, Jeremiah. Please forgive me.
How is it that the thing out of my eye?
Very unpleasant.
You see, Mr. Venus, you have to recall that I am extremely low grade.
You're not.
No. Well, actually, brain size, like physically, has very little to do with intelligence.
However, brain atrophy does have to do with how brain dead you are.
That's true.
Two very different things.
That said, and please do chime in with any insight you have on this,
Okay?
I have heard tale of a man who worked in a rather toxic facility, maybe a mine, maybe some chemical plant. And it was only found out when he was a senior citizen, getting like brain scans for various things, that his brain had been eroded by his working conditions from a typical size to closer to something like this. The implication being that since it happens slowly enough, the parts that are left learns to do what the missing parts used to do.
The brain is able to rewire, instead of air quotes, that's not the correct term. Rewire itself so that, like, if you were to suffer a traumatic accident and survive it, your brain, especially when you're younger, can like rewire itself to make up for the parts that are lost. Now, that sounds really extreme. I don't know anything about the case,
That's
but like I could see it being possible. The brain is an interesting thing. Also, he could be very much the exception to the rule.
eventually.
Yeah, people are just kind of weird.
People are weird.
Confuse us sometimes.
And given that the brain is largely the part that is responsible for making them behave like people, it's the really weird part.
I've got to say that the brain is probably one of my least favorite words.
Brains have the consistency of flan.
I don't like that.
What's a good,
What?
I don't like that.
That's a very good comparison.
Like the animals swan?
No,
Flan, like the custard.
Mexican custard dessert,
Yeah.
but a
Oh,
little bit
with the-
thicker,
the-
like if you froze it, like cold flan.
Yeah.
It's not mac and cheese.
No.
Okay.
You people have had that before? What the heck?
I've had flan, but I have not eaten a brain, but I've dissected a brain.
I saw an emergency
Sorry.
craniotomy. I had to wear goggles in case it splattered on me. Yep.
I've had flan. I have not interacted with brains of any species.
Or if you can
Not
do
even
it
in high
with your
school?
own brain.
Not even in high school, like a sheep brain or nothing?
Yeah.
We dissected frogs,
No.
They have brains.
bellied up.
They do
Very
have
little
brains.
brain access.
Contrary to
Also, I
popular
hated the whole
belief,
thing and didn't do any more than I was contractually obligated to do.
Oh, I stayed after class and took apart all the other parts.
And that is okay. That's just one of the differences between biologists and physicists.
Natural selection.
I don't do innards.
When did you decide?
Here's
you
something
wanted to be a
crazy.
physicist?
So during that
Senior year
first,
high school.
that would be weird. During that emergency craniotomy, they took out like the part of the skull to get the hemorrhage out of the brain or whatever. But then they sewed it back up, and I was like, "Are you not putting the skull piece back in?" And he was like, "No, it's gonna swell and stuff, so you gotta leave some room." And I was like, "Oh, okay, so you're just gonna have a mushy brain part on his head?" And he was like, "Yeah."
Like
And I
a
was like,
baby.
I was like, "Okay." So then he sews that up, and I think we're done. And then they start moving all the stuff to the stomach, and I was like, "What are you doing?" He's like, "Oh, you don't want the body to reject the skull piece, so we're gonna put it in his stomach till we're ready to put it back in his head." And I was like, "What?" Did not know that happened, but it
You
does.
come your own incubator.
Yeah, it's crazy.
That reminds me of the case where someone's hand got skinned and they sewed it into his stomach
Really?
to keep the exposed parts of his body
Clean.
clean and in a human environment.
That's crazy.
I would hate every minute of that.
I would be want to go, "Ugh," like as hard as I could.
Think about it though, like the skull's kind of hard.
He has a heart thing
Yeah,
just
that's
chilling in
right
there.
there.
That's so
Or
crazy.
like he has other things that he has to worry about.
Like
at one
his
time.
squishy brain
Like,
spot.
There's
Yeah.
nothing protecting his brain.
Look, if you're unconscious in a hospital room, not moving for X days,
They found him in the middle of the street,
oops.
unconscious. This guy.
Yeah, that happens sometimes.
I didn't ask if he made it because I didn't want him.
We've had people come into the Lawrence ER that like fall out in the streets of Clinton. She coded and she did not make it, which is really sad. But
That's another reason why I don't do medicine.
she did come in and like had fallen out in front of Whiteford's. And
Oh my
she had
gosh.
aspirated and then she coded.
My friend just did her first round as like an ER nurse, and she had this lady who was on bath salts, and she shot herself with a shotgun through the hand.
That happens sometimes.
I love
I could never do
Humans are
ER.
dumb.
You could never have.
I mean, it would be interesting.
We had
but-
a sweet old man come in, I mean, precious, he was like 84. And he was just trying to like help out around the house and he dropped a ham
Oh.
on his toe
Oh.
and like shattered it. I mean,
Yeah,
it looked like
ham's
squished.
It's big toe.
I'm guessing a frozen ham
Like
is
a
not-
frozen
it's
ham.
just a
Oh,
bowling ball.
I'm thinking a cooked ham in my head, and I'm like, that doesn't seem that bad.
It just really messed up, that toe just wasn't right. It
No.
was really good.
I never think that's supposed to bang that way.
Most of the ER people that are in Charleston are like very non-thankful. Like
I mean, you get a lot.
unappreciative of the fact that people are there in the middle of the night to do ER.
I mean, where I come from, if you went to the doctor or you had to go to the emergency room, you're already dead, so you just did good.
I mean,
By the time the ambulance got there, 90% of your blood's on the street.
You live far from a hospital.
Well, the hospitals were not in my area, I should say.
Okay.
Oh,
I think everyone actually has the same numbers for this one.
Yeah. I'm gonna try colors.
Last comment before physics. I'm so squeamish that when a former student needed to, do insulin because he's diabetic, and on a regular occurrence, I was fine with him doing it in the classroom. The man needed his insulin, but I made the mistake of watching him do it the first time. So just very quickly, and I immediately almost passed out.
So I'm assuming you don't give blood?
I do actually, because I have an uncommon blood type.
So do
What's
I.
your blood type?
O negative? That's the
O
one I
negative
I
want.
think it's O
It's
positive.
Huh? O positive is the most common. O negative is the least common.
O negative is,
I have a useful blood type.
O positive is very useful, but it's also very common.
as long as we know you have the Rho factor, we can dump it in your body. Because it doesn't have any of the glycolate.
Antibiotics.
Okay, I know I'm not negative, because O negative is the universal one, right?
Right.
Okay, I'm not that. Point is, I.
Do you have to look away, close your eyes?
Yes, and pretend I'm anywhere else for the next 30 minutes.
I asked him to show you because I like to watch it.
Well,
It's not take that long.
It's taking me that
No,
long.
it's the 30 minutes of, I'm in the chair and I'm looking away the entire time they're tending to the arm, leading up to the extraction and
You don't
then
wanna
the
know when
chilling
it's
out
gonna go
afterwards.
in. I need to know.
Last
I need to
thing
be
that
prepared,
they're-
or
Yeah,
I'll freak out.
like they always put the little thing over, it's like, you don't need that, I wanna see it, and they're like, no. I'm like,
I want to look at the bag, but it's always like tucked underneath, so I look at my neighbor's bag. I want to just
See.
watch it fill up with blood. I want to see how full it is.
The first time I ever had blood taken, I passed out, and they gave me those little Ocean Spray orange juices. But I had to fast for 24 hours, which is why I passed out. And so then the next time, I was actually giving blood and not getting work done, and I was like, I'm not passing out. So I drank 7 Ocean Spray orange juices, and it was a blood drive at school, and I threw up all the orange juice in front of all my friends.
That's pretty cool, actually.
It was horrible.
I don't think I've ever done it, that's cool.
But I got out of the rest of the day class.
First time I ever donated blood was on a blood bus at my last teaching job. When I was teaching high school, I was 26. And I donated blood because I found out blood type was, I was told my blood type was needed. That's what I was told. So I did it.
So is that a good thing?
Some students were there encouraging me because I was terrified. Some students were there trying to freak me out because I was terrified. After the experience, I went back to class. I started teaching because I'd been 30 minutes late. And then I turned sheet white. And my students told me you need to lay down. So I stood up to walk to the back of the room to lay down on a lab table. Then I was looking up at the ceiling. Passed out in class.
I'm sorry.
That's the first time, that's the first and only time I fainted.
If I was one of your students, I'm definitely clowning on you, bro.
So, triangle, equilateral triangle, so everything here is equidistant from one another. Goal is to find the combined total electric field right there. So there's 3 charged particles. The first 8 nanocoulomb one is going to exert field in this direction compared to the spot we're looking at. So that's whatever vector we find, whatever E field we find from this particle at this distance is going to point this way.
It's positive.
Correct. This negative 5 nanocoulomb particle is going to pull field into itself along the same line. So whatever vector we calculate for this one will also point in the same direction. The last particle, this positive one up here, is going to be pointing straight down at that spot.
No, I'm not.
Well, this is the spot we're looking at. We want
Oh, I
to,
get it.
we're tracking all of the fields as they relate to that point in space. I could fill in more more arrows for each one. And just as you trace from each particle to that spot, and you continue on, that'll be the direction it points in. So we're going to be finding 3 different vectors, 2 of which point in the positive x, 1 of which points in the negative y. So before doing any math, what quadrant is the field going to point into? fourth. It's going to go this way. Which is why the answer is in terms of degrees beneath the x-axis. So, we're ultimately just going to be forming a very funny looking triangle. So, the three particles that we have here, let's start with the anaphyllin one. So, E field 1, K times its charge. Nano is times 10 to the negative ninth. So I'm writing that as E times 10 to the negative ninth. And then divided by the radius squared. This is an equilateral triangle with sides of 0.5 meters. So the distance between this particle and this spot in the middle of one side is going to be 0.25 meters. And that's what's going to go down here. And whatever number we get here, it's going to point to the positive x.
And that's weird, right?
Thank you for catching that. That is squared. We'll do the blue one next. So E2, K times negative 5 times 10 to the negative 9. But again, that negative is not super important. What's important is we know that the vector is going to point also in the positive x. And it's going to have the same radius because it's also just half of this triangle side length away. So those are going to be our two x-axis components. And then the third one, let me label these actually. 1, 3, 2. Just the order that I'm solving before. K times 3e negative 9. The radius is going to get just a little bit funny here because we're now looking at the distance between the top point and the middle bottom of an equilateral triangle. So this one's not going to be 0.25 or 0.5.
We're just gonna, you can use the sine of 60 and solve for it.
Yes, we could do,
Or we could do the Pythagorean.
there's at least two different ways you can do it, yes. Sine of 60 would be this leg over 0.5. So 0.5 times the sine of 60 should get you there. So, however you want to get there, Pythagorean theorem or trig identities, I've got, please correct me if I'm wrong, 0.433 squared. Does anyone disagree? That's right. And that will give us some number in the negative y-axis.
What is the thing over the axis?
That is a little symbol that I am in the habit of using for vector direction. If I'm writing out like a complex multi-dimensional vector, like the one we're solving for actually, that points in the x and the y. Let's say it goes 2 down and 4 across. Some of my classes have got me in the habit of describing it as 4x and negative 2y.
That's pretty.
It makes most sense if you're doing 3-dimensional vectors, which we won't in this class. So that's a headache and a half.
Thank goodness I had to drop out 4 if I fell short.
You are valid. Okay, we have 3 different numbers here. Ultimately, they're going to add up to form a triangle that looks something like this. final answer is this hypotenuse at that angle. Why do I do this? I guess we go.
Hold on, I'm doing that.
Does it have to be that answer? Because like, my answer rounded is that answer.
That should be fine. I've got it set to where it should have a 5% degree of okayness on answers. I've set it to 7 recently, actually. No, it used to be 3. I changed it to 5.
That's fine.
That is several of the homework questions. This is going to be due Thursday night, so we still have lecture on Thursday to address any lingering questions you still have after working on it for the next couple of days. You guys feel comfortable with that? Okay. I'm going to go ahead and start letting you guys back because we're nearing the end and I don't want to hold you on a nice weather day, especially since some of you have lab next, and so I would like you to get a little bit of sunlight. Sorry we didn't have class outside. But to show you the chapter 16 stuff that we will be getting to eventually, hopefully Thursday, and that will be involved in your lab this week. So we can be backing up and heading out. You don't have to write this down. The next information is going to be about capacitors. And you get a capacitor when you have a bunch of positive charges in a straight line across from a bunch of negative charges in a straight line. So the thundercloud example is actually basically a capacitor. And what happens here uniquely is, if you have one positive by itself, you get the E field radiating outwards in all directions, which makes it kind of hard to manipulate for industrial purposes because everything's going off into different corners of the universe. Capacitors are neat because with this precise orientation of a lot of positives here and a lot of negatives here on a line, you can get nice, straight, parallel E field lines that all point the same direction. This is very nice for industrial purposes, and this, both invented on purpose and on accident, is basically the earliest form of a battery Earth has ever had.
Makes some positive batteries, especially.
They certainly do hold charge and energy in them. Yes.
Is a flux capacitor a real thing?
Not as presented in Back to the Future.
Okay. Does the Jonas Brothers also sing about a flux capacitor?
They would.
No.
All I remember, I love those movies, but all I remember from the technobabble is just that it's the circuit that lets the time travel happen. How it worked. Temporal field capacitor.
All right, Professor Crawford, I'll see you in a few minutes.
See you in a few minutes. enjoy, please rest, enjoy, get water, get some daylight. My best guess is it's, okay, the point of a capacitor is to build up and store charge in a normal capacitor. This thing might build up and store the technobabble flux energy or time energy that he's not on. Like, it might store up a temporal field instead of an electric field. And the goal being store it up until it reaches a certain critical point when you're moving 88 miles per hour.
Okay. So it just doesn't exist yet.
I don't know if it will exist as Doc Brown advertised, because if time travel is real, I don't think it's going to work the same way.
Well, probably not.
But have we harvested the lightning through a copper wire to get to the, what's it called? The time
DeLorean?
DeLorean.
I know cars have been electrocuted by lightning. I know that much.
How did Marty McFly become best friends with the doctor?
Great question.
Like in what world is a high school student just pals with like a crazy
With the neighborhood kook.
like
And like Morty.
like really good friends. Like he
They're related.
invites himself into his own house. You know, like it's not just like, oh, I kind of know this man. He's my neighbor.
I mean, a writer could come up with any reason they want. I think,
There needs to be a backstory, Back to the Future backstory.
so back to the past.
There already is that.
But technically, I guess I have two because he goes
Back to the
his
back,
parents,
like,
and then he goes
Back to the
past.
backstory.
They need like an in-between version.
Back to the mid-pole.
Back to the middle.
I mean,
Back to the right now.
considering Marty's role in filming everything, he might have just been, like, I could see Doc Brown putting posters around the neighborhood for research assistants wanted. And Marty being
Also true.
bored and
Needed money.
bored and
Yeah.
not having enough of his own money to pick it up.
Okay.
Telling you.
Have a good one.
We need a movie about it. Goodbye.
Bye.